Hello students, hi, this is Mohammad Shadan. I am working as a data scientist here with KPIT, and I'll be talking a bit about the problem statement for the challenge. And the title of the challenge is Design an Efficient Scheduling Optimization Algorithm for Electric Vehicles. So if I talk about the background of this challenge, electric vehicles run on electricity, and unlike conventional vehicles which run on petrol powered engines, electric vehicles need electric motors which get their energy from either batteries or fuel cells. Now if we talk about the vehicle scheduling problem, now this is a very conventional problem in the public transport area. And one of the main assumptions with this scheduling problem is that the vehicles run throughout the day without any interventions for refueling, or the refueling time is very less. So the problem statement here is to minimize the number of buses as well as the number of chargers based on the battery capabilities, for example the charging time or the discharge time, as well as the input parameters for the schedule. Now some of the input parameters for the schedules are like schedule parameters as well as the battery parameters. Now schedule parameters include things like distance for the trip, the time duration for the trip, the rest time between different trips, and for battery some of the parameters are like what is the charge rate, what is the discharge rate, what is the threshold for the battery. And now coming on to the deliverables. The deliverable for the milestone 1, the main objective would be to design and deploy an algorithm that would minimize the number of buses based on the given schedule, as well as to assign buses and find the minimum number of charges that would be required for the operation to complete. Now if you look at the snapshot of the problem statement, you could see a snapshot of different parameters that would be required for the optimization. And this coming on to the milestone number 2, the main objective would be to deploy and create an algorithm that would accept a schedule as input. In the milestone 1, you were given different parameters, but in milestone 2 you will be taking a schedule as input and then assigning buses after optimizing it, as well as you will need to find the number of minimum number of charges that would be required to complete the operation, and some of the input parameters would be for battery, which I just told. And in last, some of the specifications that would be required to be met for this challenge would be, first you will need to find the minimum number of buses as well as the minimum number of charges that would be required for the operation to complete. Second, we would need the output as an Excel or a CSV format, and web application running an algorithm would be preferable. So thanks a lot and all the best for the challenge.